Now I'm going to look at describing the data numerically, not just using box plots, but also histograms. And you've done histograms for a long time. We're going to talk about data that has one peak. This means unimodal, one mode. So basically, normally if we look at data, we expect it to look something like this. This is called symmetric. It's not skewed one way or the other. So we kind of, if you fold it in half, it looks the same both ways, roughly. All right. This data we call negatively skewed because we have these lower numbers that are negatively affecting the mean, the average. Okay. So that's pulling the mean down. This could be happen like if you looked at lifespans of people, how long people live. You're going to see that we're hopefully going to get a little bit high, 60s, 70s. But then as you get higher and higher to the 90s, that drops. But most people actually, there's some people who sadly die very young, and usually, serious illness or accident here. And then as we get up and up, we're getting to where we tend to go right there. So on to more positive things, like positively skewed. So positively skewed means when you have some high numbers that are pulling up the mean positively. This could be like salaries. So hopefully not many people are making too little bit of money. Most of us are kind of making somewhere between, in the middle of a 50,000 or something like that, hopefully. And then you have a few really high salaries, and this one doesn't even go super high, that pulls the average up. So usually when we're talking about the shape of the data, we're going to say if it's symmetric or it's negatively skewed or positively skewed. So let's take a look at this histogram of medical errors for 24 hospital residents. And there was one guy making a lot of residents. So these are the guys giving the medication. And I'd be careful for this guy. So when we put this on the box plot on my calculator, this is what I got. And I'll show you how to get these points here in a second. Because if you did put this in your box plot, you might not have gotten these points. And then let's take a look at this compared to the histogram. So if we trace our graph, we can see that the min is 0, the lower quartile is 0, the median is 0. Why is that? Well, we've got all these zeros, all right? Then finally we get the upper quartile is 1. I should say the max for the whisker is 2, and then the outliers at 3, 5, and 11, all right? Let me show you how to go ahead and get this box plot. So I'm going to say that this data is positively skewed. This resident here is really pulling up the average. All right. So how to get a box plot showing outliers? First of all, I'm going to show you how to clear your data list in case you hadn't done it before. So you hit clear list and then you can hit the name. And notice the names are in blue right here. So you hit shift and blue and the names are here under these buttons. Then you go ahead and hit enter your data. And the nice part is there are a lot of zeros in here. So you could lose track of how many zeros you've entered. And in fact, right about here, I'm like, do I have enough zeros? Yes, I do. So let me keep entering data until I'm done. And then I'm going to hit second in stat plot. And I want the top plot. And this time I have it changed already. That first one on the lower left, right there, where I'm scrolling to, that will include your outliers, which I would think would be generally good practice. And then you hit graph and you can see. Now, if you trace it, it will actually give you the numbers there. So if you hit this trace button right there, you can scroll through it and see the numbers. So I went ahead and pulled geometry scores from quiz 1 for one of my classes. I'm just going to call them the orange geometry class. From this fall. So here they are. And usually when I would show my students data, I would show them a stem and leaf plot, which is basically this is the front of the score and this is the back of the score. And yes, I had a 5. All right. And then there was a 28 and a bunch of 40s, a 50, a couple 60s, a bunch of 70s and a 74, a lot of 80s and 200s. All right. And if you turn this sideways, it actually looks like a great histogram, and it works pretty well that way. Well, here's the actual histogram, and I generated this online. They're kind of harder to make than you think they are. They're easier to draw by hand. And I said, well, okay, so here's the histogram for my data, and let me go ahead and do the box plot for my data. So here's my box plot that I generated after I cleared my list and put in my new data. And here's the histogram. You can see the box plot and the histogram look quite similar. The advantage of the box plot is you can really identify the median, where it's a little bit harder from a histogram. Here, the min is 5, and then we have 28, and then my low whisker, I'm going to call this low whisker, is 40, and then the Q1 is 60, the median is 70, this is 80, and that's Q3, the upper quartile, and then we have 100. So if I did my RQR, it would be from 60 to 80 or 40. I do have the outliers at 5 and 28, and I happen to know that the average from the data is 67. These guys are pulling down the average, so that's why the mean is lower than the median. So we would say that this is negatively skewed. If I'm trying to compare more than one class, basically all you're going to do is go into that stat and edit and put your data in the list, and I've already entered it because you don't need to watch me do that. And then you're going to make sure that the plots are turned on for all of them. So I'm going to show you the plot for 2, and you can see, make sure it shows list 2. It's going to default to list 1. So I'm going to show you how to change that. Make sure you hit clear to get rid of it, then hit the name you want to put in there. I didn't really want list 3 in here, so I'm going to put list 2 back. And then we go make sure the plot 3 is all set, and we have the same type, the right list. We hit graph, and you can see the data here. So now I'm tracing over here on the left through the data, and basically it gave me all these numbers. So I looked at the traces from these. I didn't actually go calculate them. I let the calculator do it for me. There is a cool stat var, which I'll show you, and it will also do your mean for you. So I pulled that off the calculator too without having to do it. You should never have to add up all your numbers and calculate the mean when you're taking statistics. Okay, so the thing you should be able to do is start making comparisons. For example, I could say that my L1 class grades are more tightly packed around the median of 70. So I can look up, there's my 70. And you can see it's more tightly packed. But I do have some outliers here. Okay, so that is definitely affecting the average. L3, that's this class here, has the highest median grade. So either I did a better job of teaching this class, or I just have kids who work harder in there. And my Q3 is 100. So it's a very high Q3. I don't even go beyond because many of my students had hundreds in this group. Then finally, well, L3 also appears to be negatively skewed because, you know, you've got these that are kind of pulling on the average down here. And L2 looks the most symmetric of the data, I would say. It's roughly symmetric. And you can tell that the mean and the median are nearly the same. In terms of medians, my highest class I would say would be the L3 class, definitely. I need to worry about these guys down here. And I've got a bit of a spread in my L2 class, which I'm okay with the spread when it's high like this. And I'm less okay with the spread when it's low. So now you're going to try this, and basically you can, I've given you a histogram already and a box plot, and you could go ahead and create the box plot if you like and calculate the numbers. I'm going to show you the answers in just a sec, so if you want to pause this, do so. But once you calculate it, you should get the min is 21, the Q1 is 32, the median is 35, Q3 is 41.5, and the max is 80. My top whisker is 49, and I have outliers at 61, 74, and 80. So you could say the distribution is skewed right. You know, most actors get their Oscar at a younger age, but we have a few people here that are pulling the average up right here. The median is 35, so half of the actresses are older than 35 and half are younger when they receive the Oscar.